Welcome to another exciting video brought to you by OpenVision Concepts Academy. So in this video, we'll be looking at geometry and there are different kinds of geometry. You have plane geometry, you have quadratic geometry, you have circle geometry, and so on. But we'll start from the basics and we'll look at trying to identify and visualize theorems associated with plane geometry. And there, if you are presented with a diagram, you should be able to write a theorem that is associated with such a diagram. All right, so we'll look at, first of all, straight lines. Straight lines. So if you have this line 1, line 2, and line 3 meeting at a point. So this first rule here says that the sum of angles at a point is 360. So it means that angle A, which is here, plus angle B, which is here, and plus angle C, which is here, will give me 360. This is the basic law for straight line, or theorem for straight line. Now, if you look at this one, it says adjacent angles on a straight line are complementary, okay, or supplementary. So this is a straight line. Let's say it is OBC, straight line OBC. So there's a point here on point B where you have another line going to maybe towards A. Okay, so it says angles, adjacent angles. Adjacent angles means this and this. They are looking at themselves. They are looking at themselves separated by this line. Understand? So adjacent angles on a straight line are supplementary. What that means now is that if I have this angle here, θ1, if I add to θ2, I must get 180. So this is supplementary. So this one now, this first one here, I say sum of angle at a point is 360 degrees. So this one is the theorem. And this one says that if I say θ1 plus θ2 is equal to 180, is because the adjacent angle on a straight line are supplementary. The adjacent angles on a straight line are supplementary. So, we're just using a simple case study where we just have two angles. So if I now still have more angles forming like this, you understand? I'm just giving more another scenario. So that here is small letter A, small letter B, small letter C, small letter D. You see that A, B, C, D, all of them must give you 180. So that's what that law is saying. Okay, so we'll move on to the next theorem. Okay, so here we have vertically opposite angles are equal. So this is the third theorem we are looking at. So if you have 4 lines or different lines meeting at a point, this is line AB, this is line AB, and line CD. So if line AB and line CD meet at this point, you understand? This angle θ1 and θ3, they are known as vertically opposite angle, and θ2 and θ4 are also vertically opposite angles. So the theorem states that θ1 is equals to θ3. The reason why this is equal is because vertically opposite angles are equal. Vertically opposite angles are equal. And in the same vein, θ2 is equals to θ4. The same reason, vertically opposite angles are equal. Vertically opposite angles are equal. So that if you have values, maybe angles here and here, once you check the criteria for this to be equal to this, because they're vertically opposite, and this is how it looks like from the diagram point of view. You see that this one and this one are facing themselves at a single point. Why theta 4 and theta 2 are facing themselves at a single point. And so vertically opposite angles are equal. So move to the next one. Okay, so we're moving to parallel lines. We looked at straight lines before, so parallel lines. So if we have line AB parallel to line CD, this is the symbol to represent that these lines are parallel. It must be present in this case. So if I have line AB parallel to CD and another line coming like this, corresponding angles are equal. What are corresponding angles? Corresponding angles are angles that form on corresponding parts of the line. So for this line AB, and that is line A, okay, let me put it a notation here. Let me call this one E. So for line, watch my marker, line EAB is an angle here. There's another corresponding shape that looks like EAB in ECD. So there is this angle that looks as if it is in the same position in the two mentioned segments. Line EAB and line ECD. This point and this point are similarly and they are corresponding. And another thing you look at that when you look at a shape and it's looking to you as if it's an F shape, no matter how distorted it is, F looks like this, is it not? So that the angle here and the angle here are the same thing. So even if the F, this side is slanting like this, but the thing is that these two must be parallel. So this one and this one will be corresponding. If the F decides to slip like this, as long as this one and this one are parallel, this line, this angle and this angle are corresponding angle. So therefore, theta 1 is equals to theta 2. The reason why that it is like that, corresponding angles are equal. Corresponding angles are equal. So that's the reason. That's the reason. We don't just derive any formula without having this all these kind of reasons. Okay, so for alternate angles we have left F shape to Z or N shape. So if you have lines forming this shape, first of all, these two lines will be parallel. A, B, and C, D, for instance, will be parallel. And because an N will have this and this parallel, it must be parallel, or Z parallel. I cannot write N like this. This is not N. This is not N. It's not a symbol N. So the N, the two lines running down will be parallel. The Z, the two lines running by the sides should also be parallel. So for this situation, if I have A, B, and C, D parallel, and a line joining the ending point of AB to the starting point of CD, this angle and this angle will be equal. So therefore, theta 1 is equals to theta 2 in this case is equal. The reason is that alternate angles are equal. Alternate angles are equal. Okay, so that's the reason. That's the reason. Okay. So, and finally, under parallel lines, if I have a U shape like this, theta 1 here and theta 2 here are supplementary because they are co-interior angles. So co-interior angles are supplementary. How do you get to the point where you see this and they call it co-interior angles? If you see a shape where this line, let me call here A, B, C, D. If line AB is parallel to line CD, that's number one. Then I have a line joining the end of AB to the end of CD. Understand? The angle formed by line AB and BC is equal to the angle formed by line DC to B. The reason is that co-interior angles are supplementary. No, not equal, sorry. Supplementary means theta 1 plus theta 2 is equals to 180. That's what this means. That's what it means. The reason being that interior angles are supplementary. When you say supplementary, two angles will give you 180 degree. That's supplementary. That's what it means. Two angles will give you 180 degree. So if this one is 90, this one will be 90. If this one is 100, this one will be 80, and so on. The two of them must sum up to give you 180. That is what supplementary angles mean. So if you have co-interior angles, they are, both of them are together, they are interior. Actually, if I subtend a line like this and subtend another line like this one is exterior angle. Let me call it beta 1, and this one beta 2. They are exterior angles. Why? Because they are outside. They are outside. They are exterior to this shape. This shape. If I close this shape like this now, I'm putting broken lines to show that they are not originally in the initial diagram I'm drawing. Any broken line you see here, they are not initially in the diagram I drew. So if I close this one like this, I know that this one they are parallel. Of course, they are parallel. Let me put second kind of parallel. So exterior angles are outside the shape, while interior angles are inside the shape. So co-interior angles are supplementary. Why? Because they are co-interior angles. All right. So we'll move on to triangle geometry. Okay, so we move on to the geometry of triangles. A triangle is a three-sided shape, 1, 2, 3, with 3 angles inside. With 3 vertices, 1, 2, and 3 vertices. So the interior angles of a triangle is supplementary, meaning that if I add all the angles inside the triangle, I will get 180. So this can be written as angle A plus angle B plus angle C is equals to 180. This is another theory. The interior angles of a triangle are supplementary. So for this one, the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Exterior angles are angles outside. So this one is outside. If I extend the line, this is a triangle. If I get to this point and extend the line, continue as if it is still straight, as for straight line. Just continue in a straight line. Understand? If I extend it, the angle formed here, that is the exterior angle, is equal to the sum of these two interior angles. If I come here and I extend it like this, so that this is a straight line all through, and I have this as theta 1. So theta 1 will be sum of two opposite interior angles. Let me call this one C. Okay, so I will write out the formula for theta 2 and theta 1 and tell you their reasons. So theta 2 is equals to A angle plus B angle. Angle A and angle B are opposite to this guy. They are opposite to this theta 2. So this theta 2 is exterior angle, but the two opposite interior angles are equal. If you add them, they are equal to this. Or I can say theta 1, we are looking at here now, this theta 1. Theta 1 is equals to angle A plus angle C. Both of them are the interior angles that are opposite to theta 1. So the reason why these two equations are true is because the exterior, either this one or this one, they are both exterior angle. Exterior angle is equal to the sum of two opposite interior angle in the triangle. Interior angle in a triangle. So we are building up our knowledge based off theorems. Even from here, I can see another theorem that says that this and this are what? They are supplementary because they are angles on a straight line. So from here, I can say angle C plus theta 2 is equals to 180. The reason being that they are angles on a straight line. And from here, I can say angle that from this center one, I can say angle A plus angle B plus angle C is equals to 180. Why? Because the interior angles in a triangle, they are supplementary. Okay, so we are building up our knowledge base because we are going to be solving some complex problems in this video series. Okay, so we go on to the types of triangle. So we have the right angle triangle. The right angle triangle is a triangle that has one side of it as 90 degrees, as in the two lines are formed at 90 degrees. So if I have side A, B, C, angle B, angle BCA, that is the angle BCA. That's how you write it, angle BCA. That's the angle at C is equals to 90 degrees. So for this right angle triangle, line AC plus line AC square plus line BC square is equals to line AB square. So this is the Pythagoras theorem. It means that this AB line is called the hypotenuse. I'm trying to just define this right angle triangle, for us. So these are the features of right angle triangle. One of the angles is 90 degrees. Of course, the sum of angles in a triangle is equals to 180 degrees. For equilateral triangle, all the angles are equal and all the sides are equal. So I have it A here, A here, A, denoting that all the angles are equal. And if the angles are equal, it means that all of them are 60 degrees. So if I have big A outside, uppercase B and uppercase C, that's forming the vertex of this triangle. This is an equilateral triangle because angle A is equals to 60, angle B is equals to 60, angle C is equals to 60. So all angles are equal, all sides are equal. So I have line AC is equals to line BC is equals to line AB. They are all equal. They are all equal. That's for equilateral triangle. So for isosceles triangle, the base angles are equal. So this is B, this is B, this can be A, something different, but these two are equal. The base angle are the angles at the base. So for isosceles triangle, the base angles are equal. Base angles are equal. So I have B, angle B is equal to angle C. And these two lines are also equal. So if you say I am drawing equal lines, if I do 2 marks here, I'll do 2 marks here. It shows that these two lines are equal. I'm doing 1 mark here and 1 mark here, 1 mark here. That means they are equal. If I do 2 marks here and 1 mark here, 1 mark here, it means that these two lines are equal, but this one is not equal to them, it's different. That's how you denote it in geometry. So for this one, I have it as 2 equal strokes like this, showing that these two lines are equal. So 2 sides are equal and 2 base angles are equal for isosceles triangle. For scaling, angles are not the same. At the same time, the lines are not the same. So this is scaling. But generally for triangles, the summation of the angles, interior angles in a triangle will give us 180. Or you can say all the angles in a triangle are supplementary. So we go into what we call congruent angles, congruent triangle. Congruent triangle. Let me quickly just describe the concept of congruent triangle. So congruent triangle, congruent triangles. There are conditions for us to arrive at congruent, to have 2 angles that are congruent, or to test for congruency. If 2 triangles are to be congruent, number one, all sides are equal. All sides are equal for congruent angles, or to test for congruency. Number 2, for the two angles, two sides are equal and one angle also equal. So two sides are equal and one angle is equal for the two triangles. Number three condition for congruency. That is another condition that is either you have this met or have this met or have this met. So I am number three now. There are four for us to establish that two triangles are congruent. Two angles and one side. So if you have two angles, here it was two sides. Now you have two angles are equal, and also, and at the same time, one side is equal for the two triangles. And number four condition is that if you have two right-angle triangles, to be congruent, if you want to test for congruency or want to know whether they are congruent, the hypotenuse of one side of the triangle is equal, and also one side. Okay, so for a right angle triangle, comma. So one side and the hypotenuse are equal. Okay, let me just use diagram to explain this for congruent angles. Congruent angle is that if you have two angles are congruent if they are the same. But they have to meet any of these conditions. So if I have, for condition one, number one, I want to use diagram to explain it. If I have a triangle like this triangle A and this triangle B, these two triangles are congruent or the same if all the sides are equal. That's what this one means, number one means. So these two triangles are congruent. You see that all the sides. So if I have 5 cm here, 5 cm, 5 cm here, 6 cm here, 7 cm here. Okay, sorry about this. I think I should do it like this. Yeah, it's all right like this. So if I have 5 cm here, 6 cm here, 7 cm here, you see that these two, so that this side of this triangle A, is equal to the side of triangle A or B. This side of triangle A is equal to this side of triangle B, and this side of triangle A is equal to the side of triangle B. So this first condition satisfies congruency. So these two triangles are congruent. Now, second condition, if two sides are equal and one angle is also equal. So I draw triangle A here again, triangle A, and this triangle B. Okay, so if I have two sides, this one and this one, this one and this one, then this angle is θ1, here too is θ1. If I have this condition, they are also congruent. So that if I put a value here, if I put 5 here, 5 cm here, 6 cm here, and 60 degree here 60 degree, then 5 cm and 6 cm. For instance, I'm just giving an example. It means that these triangles are congruent, right? Because they have two sides are equal. This side corresponding to this side equal, equal, and the angle in between them, or one of the angles, is they are equal. The third condition, again, two angles are equal and one side is equal. So two angles are congruent, triangles are congruent, triangle A and triangle B. Triangle A and triangle B, they are congruent if two angles, this θ1 and θ2, the same here, θ1, θ2, you see two angles are equal and one side is also equal. So the last condition that can be satisfied is for right angle triangle, congruency can also exist for two right angle triangles, triangles A and B, right angle triangle A and B, if I have the hypotenuse the same and one side the same, already this and this, they are already the same. So technically speaking, but we are using a condition 2 to describe this. It fits in because this angle is already the same, whereas one angle already the same and two sides the same. So for right angle triangle, if the hypotenuse are the same for the two of them and one of the sides are the same for the two of them, it means that the triangle, the right angle triangle, is congruent. So we looked at plane geometry introduction. We saw how straight lines we can derive some theory from straight lines, from parallel lines, corresponding angles, adjacent angles. We saw triangles and the types of triangles that we have and the congruency of triangle. So I hope this video has been informative for you. I'd like to thank you for viewing.